Here's the next question, number 34. In the figure, the admittance values of the elements in Siemens are YR, which is 0.5 plus J0, Y1 is 0 minus J1.5, YC is 0 plus J.3 respectively. The value of I as a phasor when the voltage E across the elements is 10 angle 0 volts is, okay. So here we have our elements, our three elements, resistor, inductor and capacitor. I believe this is an L, YL. And here we have I. Okay, so YR, YL and YC has been given to us. The three elements are connected in parallel. We also have our voltage E given as 10 angle 0. So first let's convert all these three values given YR, YL and YC in terms of polar coordinates. I'll write that down here. So we have YR as 0.5 plus J0 and that would be 0.5 angle 0. Next we have YL, which is 0 minus J1.5 and that's 1.5 angle minus 90. And then we have YC. YC is 0 plus J.3 and that's 0.3 angle 90 degrees. Okay, so these are our values. Now we will use these polar coordinates in order to solve. Now here we have our current from the source which is passing through each of the three branches. Now let's call the current that goes through YR as IR. And the current that passes through this element over here to be IL, and the current that passes through the capacitor to be IC. So now we are going to calculate what the values of IR, IL and IC are. Okay, so let's start by finding out the value of IR. Now the current through the resistance, the expression can be written as the voltage E times the admittance YR, and that would be 10 angle 0 times 0.5 angle 0. Multiplying the two, that gives us 5 angle 0 amps. Next, we calculate the current through the inductor IL. So IL is E times YL, that's 10 angle 0 times the value of YL we found to be 1.5 angle minus 90. Multiplying the two, we get the value as 15 angle minus 90 amps. Similarly, the next one we calculate for IC. IC is E times YC, that's 10 angle 0 times the value that we found earlier was 0.3 angle 90. Multiplying the two, that gives us 3 angle 90 amps. So we have the value of the three currents. Now to find out the phasor. The phasor current of I is the sum of all these three currents, IR plus IL plus IC. And that would be 5 angle 0 plus 15 angle minus 90 plus 3 angle 90. Now in order to add the three, we would have to convert them into rectangular quadrants again. So let's do that now. Now 5 angle 0 is 5 plus J0 plus 15 angle minus 19 is 0 minus J15 plus 3 angle 90 would be 0 plus J3. I hope this is clear so far. Now we add everything up and this will give us a value of 5 minus j12. Now our options given in the question are in the form of rectangular coordinates. So 5 minus j12, let's see, 5 minus j12 is option D. So here for this question the final answer is 5 minus j12, option D.